All right. Back in the lectures for tertiary detail, we kind of went over this concept already, but I want to review it again. Um, Black and white is kind of a way we can paint math. So if you look at a lot of attributes inside the PXR surface, and we'll jump into it pretty quick here, you can see they have numbers as their inputs. So if we want to add complexity to our models and variance to our models, we need a way that we can paint numbers. And if we had to actually paint the values on a picture, it would be quite difficult. So we can use black and white and think of black and white, you have your value channel. That value would go from 0 to 1. So it gives us a really easy way to look at an image and kind of picture math as a value range. So if we jump into Maya here, all I did is create a sphere. I'm going to go into the preset browser here for RenderMan, and I'm going to, nothing selected out here. Let's just right click and add, or just import one of these guys. I'm going to now add to this surface a PXR surface. So I'm right clicking and I'm assigning new material. Under RenderMan, go to BXDF and assign a PXR surface. And I can go to the attributes of this surface. And now if we look through things like the roughness, you can see that that's a numerical value. So right now, let's just give this some spec. And let's actually render it. And we'll turn on the IPR so we're rendering in the window here. You can see the specular highlight right here is pretty tight, right? It's not a big circle, and this is reflecting the sun that's in the background. If I up my roughness value, you can see that highlight gets bigger and it almost starts going away. Now if we had areas on here that maybe had like oil or paint on them or a clear coat or something like that, we'd want certain areas shinier and we want certain areas duller. And in order to do that, we would need a way to paint those values. And now that I know like 0.072, if we look at that roughness value, gives me a really tight highlight, and let's say 0.5 gives us a really dull highlight, I could go into Photoshop and I could start picking those value ranges and painting a map for it, right? And then when I bring it back in here and hook it up, I'll have some areas that are dull, just like this, and some areas that are very shiny, just like this. And that helps me to build complexity in my shaders. And the more complexity we have to our shaders, if we do it in a smart way, they'll start looking more photoreal. So that's really what I mean by think of math in black and white. It just gives us a way to paint these numerical values and start using maps to add complexity to things like roughness. And if we go under like glass, we have refraction gain, reflection gain, roughness here as well. All these that we're going to learn about coming up that are numerical values, that's something we can paint black and white maps for.